Welcome to this tutorial on superimposing structures using Jmol. In this tutorial, we will learn to load two or more models on the Jmol panel, translate and rotate models on the panel, superimpose models using script commands, compare RMSD score for the superimposition. Here I am using Ubuntu Linux OS version 20.04, Jmol version 14.32.80, Java version 11.0.16, a working internet connection. To follow this tutorial, learners should be familiar with chemistry topics from undergraduate courses and basic operations of Jmol. For the prerequisite Jmol tutorials, please visit this website. The input files required for this tutorial are available in the code files link. Please download and extract the files. Make a copy of all the files and then use them for practicing. Comparing 3D structures of molecules is useful in stereochemical analysis, predicting molecular functions, drug discovery and design of ligands. Here I have opened the Jmol interface. Let us begin by comparing structures of simple organic molecule lactic acid. We will load the model of lactic acid from the database. Open the File menu and select Get Mol option. Type lactic acid in the search field and click on the OK button. The model of lactic acid is displayed on the screen. The central carbon in lactic acid is chiral. It is attached to 4 different groups. It exists as 2 enantiomers: L-lactic acid, S-lactic acid or plus lactic acid, and D-lactic acid, R-lactic acid or minus lactic acid. These two molecules are non-superimposable mirror images of each other. Let us assign the RS configurations using CAN INGOLD PRELOG priority rules. Rotate the model such that the hydrogen is at the back of the central carbon. The groups around the central carbon atom are arranged anticlockwise. Hence, this model is of S-lactic acid. Please go through the additional reading material for more information. Let us save this model. Click on the Model Kit icon. From the menu, select Save File option. Save dialog box opens. I am saving this file to the Jmol folder where the jmol.jar file is located. Details on how to change the default directory can be found in the additional reading material. I will name the file as slacticacid.mol. Select the files of type as mol. Click on Save button. Now let us convert the S-lactic acid model into R-lactic acid. For this, we need to break the bonds and reconnect the bonds. We can swap the position of any two groups to create the model of R-lactic acid. Let us keep it simple. I will choose to swap the positions of the hydrogen atom and methyl group. Open the Model Kit menu. Make sure that carbon is selected in the elements list. Click on the hydrogen atom to replace it with the methyl group. Now open the Model Kit menu. Select hydrogen from the elements list. Click on the carbon atom of the methyl group to replace it with hydrogen. We have now swapped the positions of hydrogen and methyl groups. Let us rotate the model in such a way that hydrogen is at the back of the central carbon atom. Now, after assigning the priority, the groups are in clockwise direction. This is a model of R-lactic acid. As demonstrated before, let us save the model on the panel as rlacticacid.mol. To compare the isomers of lactic acid, we need to load both the models on the panel. This can be achieved by different methods. First, I will type the script commands on the console to load the models. Open the console using the File menu. I will resize the console to see the models clearly. We will load the already saved model of S-lactic acid. On the console window, at the prompt, type load append, followed by the name of the saved mol file for S-lactic acid, slacticacid.mol. Press enter. Console shows two models. To view both the molecules on the screen, type the command framall. Press enter. Both the models are displayed on the panel together. We have to separate them. Close the console window. Open the Model Kit menu. From the options, select Drag Molecule option. Place the cursor on any atom of any model. Hold the left mouse button and drag the mouse. Place the model next to the other model. Leave the hold on the mouse button. To rotate the model, place the mouse cursor on the model. Press the Alt button and left mouse button and drag. I will adjust the models in such a way that they look like mirror images of each other. These two structures are enantiomers. They are non-superimposable mirror images. Let us check if they are indeed non-superimposable. We can manually superimpose one structure over the other. Click on one structure, drag and put the structure over the other. As you can see clearly, the groups other than hydrogen are not aligned. Hence, they are non-superimposable. Let us separate the models and look at other options to superimpose. Script command with compare command word can be used for superimposition. The command compares two models and reorients the first model relative to the second. The reorientation is based on the given atom-atom coordinate pairing. The command line with the following syntax will be used for the purpose. Compare model 1, model 2, smarts or smiles, smart string, translate, rotate. Please use the link below to know more about compare command. I have modified the above command line as shown here to suit our purpose. Here, compare word is followed by the model number. We have loaded two models on the panel, D-lactic acid and L-lactic acid. 1.1 refers to the first model in the file, and 2.1 refers to the second model in the file. Smarts refers to the substructure description. The string of atoms to be compared are in double quotes. These are atoms in the first structure that correlate one-to-one with atoms in the second structure. Then find the rotation and translation that best aligns them. 2.0 refers to the number of seconds to complete the translation and rotation animation. You can change the number here as per your preference. Open the console using the File menu. Type the compare command as shown here in the console window. Press enter. The two structures are now superimposed. On the console window, you will see a message in blue. It shows the RMSD score for the superposition. Root means square deviation. It is the measure of the average distance between the atoms of superimposed models. It is measured in angstrom units. The smaller the RMSD value, the more similar the two structures. An RMSD score of less than 2.0 angstroms is observed when the structures have good superposition. Here, RMSD score of 4.41 angstroms indicates the similar structures. The RMSD score can vary slightly for the learners. Let me demonstrate this with one more example. We will compare the structures of three simple carbohydrates D-maltose, D-glucose and D-mannose. Their structures resemble very closely with each other. The mol files for the models are shared in the code files folder. Please download and use them as input files. I will open a new Jmol window. Another way to load and append the models on panel is by using the toolbar. On the toolbar, click on Open a File tool. Open dialog box opens. Select the saved input file for dglucose.mol. Click on the Open button. The model of open chain D-glucose is displayed on the screen. To load the second model, click on the Open a File tool. Once again, the Open dialog box opens. Select D-maltose.mol. Check the checkbox for Append Models. This checkbox is available on the right side of the Open dialog box. Uncheck the other checkboxes if they are checked. Click on the Open button. The model of D-maltose is displayed on the screen. Similarly, load and append the model of D-mannose on the panel. To view them all in one frame, click on All Frames tool on the far right end of the toolbar. The three models appear superimposed on each other. Separate the models on the panel using Drag Molecule option in the Model Kit menu. Place the models as shown here. Let us compare the models with one another. The RMSD score for the comparison will allow us to determine which carbohydrates are similar. Open the console using the File menu. I will resize the console window to see the superimposing clearly. At the prompt, type the following command. Here we are comparing Model 1 and Model 2. Model 1 is D-glucose and Model 2 is D-maltose. We are using the smiles, which means we are comparing the whole molecule. Press Enter. The models are superimposed on each other. The RMSD score of 0.79 angstroms is displayed on the console. Let us separate the superimposed models. Use the Drag Molecule option in the Model Kit menu to separate the models. Press the up arrow key to get the previous command at the prompt. Edit the number for the model as 3.1 in place of 2.1. Here we want to compare Model 3 with Model 1. Model 3 is D-mannose and Model 1 is D-glucose. Press Enter. Models of D-mannose and D-glucose are superimposed on the panel. The RMSD score for this superposition is 0.638 angstroms. This value is slightly lower than that for D-glucose and D-maltose. Again, separate the models on the panel. On the console, press the up arrow key and edit the command as follows. Edit the number for the model as 2.1 instead of 1.1. Press Enter. Now models 2 and 3 are superimposed. These are models of D-maltose and D-mannose. The RMSD score here is 0.578 angstroms. Structures of D-maltose and D-mannose resemble more closely when compared to other pairs. Pairs of structures D-glucose, D-mannose and D-maltose, D-mannose are epimers. The pairs of structures D-glucose, D-maltose are diastereomers. Let us summarize. In this tutorial, we have learned to load 2 or more models on the Jmol panel, translate and rotate models on the panel, superimpose models using script commands, Compare the RMSD score for the superimposition. Here is an assignment for you. Explore the compare command and superimpose models of your choice. The video at the following link summarizes the spoken tutorial project. Please download and watch it. We conduct workshops using spoken tutorials and give certificates. For more details, please contact us. Please post your timed queries in this forum. The Spoken Tutorial project is funded by the Ministry of Education, Government of India. The script for this tutorial is contributed by Snehalata Kaliappan. This is Madhuri Ganpati from IIT Bombay signing off. Thank you for joining.